In this next video, we want to look a little more at continuity. So in the previous one, we looked at checking continuity at a particular point. But if you follow along in the notes, we also talk about continuity for a function overall. And I made a kind of statement that for our functions, the kind of basic functions we'll look at, polynomials, fractional functions, functions involving radicals like square roots and cube roots, our trig functions, all of those functions for the most part are pretty well behaved. So as long as they're defined, they're actually going to be continuous. The one exception is piecewise functions, which as long as the pieces are defined, it's okay for the most part, but we do have to check the points where it switches from one function to the next. So let's consider now some examples where we want to check the continuity of a function. So first off, let's consider this rational function. As long as this rational function is defined, the limit is going to be the same as the function value. And that was one of our rules from earlier. So to check to see when this thing is continuous, we actually want to figure out when is it not continuous. So when is it undefined? When is this thing undefined? Well, remember, a fraction would be undefined when we have division by 0. And so we solve to figure out when is the denominator, x squared minus x minus 12, equal to 0. When is that going to be 0? There's different ways to solve that. You could use the quadratic formula. This one factors pretty easily, though. Things that multiply to be negative 12 add to be negative 1. So it'll factor is x plus 3 and x minus 4, giving us two values that make the denominator 0, negative 3 and positive 4. So when it comes to the question now of continuity, those are the times when the denominator will be 0. And so therefore we can say this thing is continuous as long as x is not those numbers. Any other time we're going to be okay. Any other time we're going to be perfectly fine. We're not going to have an issue. But at those values, we are going to have an issue. So it's continuous as long as x is not negative 3 or positive 4. Now, for the most part, I'm fine with that notation, but a lot of the online homework does ask for interval notation. So writing that interval notation, it'd basically be everything on the number line except negative 3 and 4. And how would we write that? Well, it'd be the interval from negative infinity up to negative 3, union from negative 3 to 4, union from 4 to infinity. So that's the textbook way of doing it. You will, on some of those homework questions, be asked to use interval notation, so you do have to do that. Okay, so continuity, again, for the most part, is going to be tied to when is it defined. Now, if we have another example here, like a trig function here, g of x equals cotangent x. G of x equals the cotangent of x. Well, we ask ourselves, when's cotangent undefined? And maybe you remember that, and maybe you don't. What I would remember is that cotangent is cosine over sine. And so my problem comes down to, I just need to know when is sine 0. When is sine going to be 0 to make it undefined? So that's where I recall my unit circle definition. And remember that sine is the y-coordinate of the points on the unit circle. And so that's going to be 0 when x is 0, or around here at pi, or again over to 2 pi. Over to 2 pi. Okay, so that is when sine of x is going to be 0. And so anytime, kind of following that pattern around, we can keep going around the circle. 3 pi, 4 pi, go back the other way, negative pi, negative 2 pi. So in general, it's going to be continuous as long as x is not a multiple of pi. And here's one where you wouldn't really be asked to do interval notation everywhere because, how could you do that? Right? It's an infinite interval. So here we kind of have to use this shorthand notation. Now they could say, when's it continuous on the interval 0 to 2 pi? And then you would be excluding 0, pi, and 2 pi, and you could write that in interval notation. Okay, we're going to look at another example of continuity with a piecewise function, but we're going to wait and do that in the next video.